Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast again. And this is another article review of some of my favorite papers from 2020. In this one, I really like this paper because it revisits a really classic study in motor control that Lee et al., David Lees et al.'s famous study of long jumping, which was published in 1982, called The Regulation of Gait in Long Jumping. As I said, this is a classic paper in motor control, and I would encourage everyone to go read it. So, for those of you that listen to my content regularly, I've probably told you before that my dissertation and my graduate work was focused on time to contact, right? What information we use to judge time to contact and use to control our movements, right? For example, intercepting a ball or avoiding colliding with something in driving and so on. And of course, one of the major figures in that research area is David Lee. And David Lee has always been one of my research heroes. I've been lucky to meet him and talk with him a few times. One of the reasons I really love David Lee's work is because he combines both kind of a lab, a researcher's and academics kind of skill. He's an incredible mathematician, has incredible ability to break down and understand information, but he also really captures the heart of kind of Gibson's ecological view, in my opinion, because he really emphasized doing research on real world issues, right? So instead of studying all the time to contact in a lab using a research task or a really basic task, he talks about driving in his very first paper about tau. In this one, he's talking about long jumping in athletes. Another very famous paper, he talks about how birds control the closure of their wings as they dive into water catching a fish. In another one, he talks about how tau babies use tau information in breastfeeding, right? So he has very, very original ideas of how to apply his ideas, which I really, really appreciated. And reading just made it much more interesting and exciting for me when I was a grad student. So as I said, this paper on regulation in gait and long jumping is one of a classic in Lee's time to collision work, showing. So what he did was measure, look at a bunch of long jumpers running up to the board and hit, as most people know, in long jumping, you have to run up to the board as quickly as possible. You have to take off on or before the board and then jump as far as possible. If you go across the board, it's a foul and the run doesn't count. And what Lee found was that, shown in a couple of graphs, this is the stride number, where on the far left is the first stride, on the far right is the last stride before you hit the board. This is the length of the stride. What he found was that runners really aren't doing much in the early part of the run up, right? The stride lengths are roughly the same. They're getting a bit longer. You can see the variability is not the variability represented by the size of the bars. Isn't the standard deviation is not really changing much. It's all happening in the last few strides, right? So these percentages are showing the amount of the run up that was adjusted in those strides. So in the last few strides, they're making huge adjustments, hugely variable movements from run to run, so that they time their run to hit the board to the takeoff. You can also see this in this plot. So there's this buildup of the standard error that's suddenly decreasing, right? It's decreasing in the last few steps, right? And so Lee put this forth as evidence of online control, perspective control, right? This is the classic funnel pattern of online control, where you start with high variability and then in the end it goes down to very low variability that's evidence of controlling a movement online. You cannot make variability reduce during a movement if you're using a pre-programmed offline movement, right? The only way that variability can decrease while you're moving is by controlling online. And of course, Lee proposed that what people were doing were controlling the last few steps before the takeoff using tau, right? Information about the visual information about the gap between you and the takeoff board, the time remaining before you're going to hit the takeoff board, right? So this is like I said, a very famous paper in the research on tau and time to collision and online control, perspective control. So as I said, I would recommend that everybody go and have a read of it. This current study I want to talk about from this year was kind of building on this. It was a study by McCosker and colleagues looking at basically making the same type of measurements that David Lee did, and but kind of putting a new twist on it by addressing some interesting questions, kind of what you're supposed to do in research, right? Build on previous studies by asking new questions. And the question they were interested in was, first of all, do these control laws, can you see them in actual competition, right? Lee obviously had people come out to a training center and just do these as part of a study. In this paper, they're going to actually measure the run-ups during real competitions, right? Second, is there effective skill level, right? So people in Lee's study seem to be regulating, and what he found was he measured their biomechanics too. They were actually measuring the vertical impulse, essentially the height of their stride, was being regulated based on the time to contact tau information. So he found this control law, this information movement coupling. What they wanted to ask in this study is this coupling, this control strategy, if you will, the same for jumpers of different skill levels. And also they wanted to ask, what's the difference between a legal jump where you hit the board you take off before the board and it's counted, versus a foul where you take off too late and go across the board? Can we see a difference in the control strategy that was used? So to do this, they took, this was done in Australia during 8 different competitions. So what they did was took a high-speed camera, put it kind of beside the course, the run-up, and they filmed people, and then they used analysis. I think they used Dartfish to break down the movements, the different steps. So they broke it into 18 different steps. And there were 8 international athletes in the study that had competed in an international level, either the Olympics or the World Championships or both, and 18 national level who competed at national level events but never on a world stage. Okay, so very nicely designed, clean study. Okay, and again, I love this because this is field research, right? This is taking it to the field. These kind of interesting research questions. So what did they find? Okay, so what we'll want to look at here first is the results from the international level, okay? So what's shown here is the standard deviation of the toe board distance. So the standard deviation of when you make your first step, how far away are you from the board? Okay, when you make your second step, right? And they've plotted these in reverse order. So 18 is your first step, 0, the board is over on the right side, right? So they're talking, if we take a bunch of different run-ups from elite athletes and we measure the standard deviation, how variable it is, what do we see, right? First of all, you can see the same basic control strategy is being used, prospective online control, right? The variability starts out very, very high at the start of the run, right? And goes down and down and down until we get closer to the board, right? And until it's very at the board, the runners are almost hitting the exact same position on every run up, which of course is what you want, right? You want to take off as close as possible to the board. So this is, as I said, consistent with Lee's finding that this is prospective online control, right? You cannot, this reduction in variability, right, could not be achieved if you were using a rhythmic pre-programmed movement, right? This reduction going down and down and down can only occur if you're using controlling your movement, adjusting it online, right? This is what we commonly call the classic funnel pattern of variability you get for prospective control. Variability starts broad, like the big end of a funnel, and narrows down as you go through the action, okay? This is also in our journal club talking about prospective control. This is also a point I like to make, right? This kind of goes against a long history of research in psychology and motor control, focusing on reaction time, right? What happens at the start of a movement. Here's, again, evidence. What happens at the start of a movement is really not as important as we thought it was, right? If you're using online control, it doesn't really matter how you started, okay? But a couple other more subtle details about what you see in this. First of all, one thing to notice is the curves go down for a while, then they hit a plateau, a flat spot in variability, then they go down again, right? What other research has shown, and they saw in this study, during these plateaus, what you could see is that person is not actually regulating their step anymore based on visual information. They're just, because the variability is not decreasing anymore, They're just doing kind of a very rhythmic stride. The reason that's important to do and not regulate all the way along is because those flat spots allow for greater buildup of speed, right? Regulating, adjusting your step based on visual information, it may be slower than just kind of, doing a very rhythmic sprinting. The other main thing to notice that, and we'll see, is very different from the other skill level is the athlete in international level and kind of lead athletes are making lots of adjustments early on at the very first steps, right? We're getting a huge reduction in variability right from the start of the run up. And then we're getting another major one starting about step 5. Okay. And this was calculated. The authors used a calculation for this, and they found that about 48% of the total adjustment in stride was made in the run up was made in the first 4 steps, and about 30% was made in the last 4 steps. Importantly, and in this graph is shown the difference between the legal and the foul. Okay, what they found was in the foul, where they went across the board, there was less adjustments early on, about 39%. Okay, what's happening there, and we'll see this we've reflected in the lesser skilled as well. If you don't make enough adjustments early on, you leave too much to do at the end, right? You have to adjust your strides really quickly and at the end to hit the board on time. If you leave too much, you're not going to be able, it's not likely that you're going to be able to make the adjustment, right? So it's important to do the adjustment all along. So that was for the international level. What did the national level runners do? You can see it's a very different pattern. Overall, it's essentially the same control strategy. You're getting this perspective control and a reduction in variability. But the essential difference is there's much less regulation and adjustment going on early in the movement, right? Remember, international levels were about 48% of the movement was made in the first adjustment was in the first 4 steps. In this study, they find that only 32% of the adjustments were made in the first 4 for the lesser skilled national athletes, and 47% were made in the final 4. So kind of the exact opposite. Okay. And this is essentially, if you remember back to the first figure I showed, this is what Lee found. Lee was probably, I can't remember what skill exact parameters of the participants, but he found that they were essentially using this mostly late control adjustment strategy. So this points to one of the reasons why these people are not as skilled, right? Their strategy is not as efficient. You're leaving too much to do at the end. Okay, so that's an important finding. So overall, what can we conclude from this? Well, I think it follows on nicely, builds on David Lee's classic study very nicely. What we're seeing is the athletes seem to be using the same basic strategy that Lee proposed, that we're using time to collision information, tau information about the time to contact with the takeoff board to regulate the stride, okay, in particular the vertical impulse of the stride. But we can see it's done in different ways for the different skilled levels. The more skilled international athletes in the study were exhibiting more functional variability early on, right? They're adjusting their stride length to get timed up with hitting the board very early in the movement, right? They're decreasing the variability. So they're spreading out the adjustments they need. Whereas the lesser skilled are doing much less regulation early on and saving it all to the last few strides, right? They're doing 48% in the last 4 strides versus 30%, right? So this adjustment based on tau information is it's much greater chance you're going to miss the board if you're putting it all in the end, okay? So importantly, I think for me, what this shows one of the ways that we can find a difference in skill level, right? It's not a difference in what information is used, so they seem or how it is used. So they seem to be using the same information movement coupling, right? They're coupling tau information about the time to collision with the takeoff board with the vertical impulse, which they did analyze that in the study. They're using that same basic control law, but the difference is when they're using the information, whether they're using it early in the movement or versus late in the movement. So I think that's a really interesting finding in one of the differences we can get. And this actually is different than some other work that is shown another way you can find a difference between people of different skill levels in this type of task is you do find they do couple to different information sources. I mean, they're coupled to different movement parameters. So Bill Warren and colleagues have done a study. You can kind of refers to this. You can look at this different ways of controlling the stride. They found what's been found in some studies that some lesser skilled athletes can use a different movement parameter, the length of your stride horizontally, to control the run up, whereas more skilled tend to always use the vertical impulse, with which is much more efficient. So whereas in this current 2020 study, we see there's a difference in when the information is used, you can also see we can get a total different in the actual movement parameter that the information is coupled to. So we can get lots of different types of differences as a function of skill level. Also, wanted to point out that this kind of basic pattern of when the information is used is difference in when the information is used. It kind of parallels one of my findings in my recent study. I kind of like to try to tie these into some of my work if I can. So in my batting study, what this is showing is the variability, the standard deviation of the different phases of a baseball swing. So the pitch is occurring, they're hitting on the far right. This is when their foot lands, when they shift the weight forward, when they actually start the movement of the bat. And what I've shown is two sets of data from a training study I did before training and after training. What you can see is before training, people are doing most of the regulation of the swing timing in the actual swing, right? Adjusting the actual swing movement when it starts and kind of the speed and adjustment. Whereas after training, they're doing much more adjustment all along, right? So the variability is significantly decreasing in the landing to waiting phase and the waiting to swing phase. So all phases of the movement. So again, this work seems to parallel what was found in this long jumping study. With more skill, in this case, developed through training, you get more adjustments happening throughout the action, not just putting it all in the end, right? So I think that's kind of a parallel finding. The last points I want to make are kind of the authors have some important implications for training. So, of course, since this is online regulation, functional variability coupling, like we need to give athletes the opportunity to develop that in practice, right? By having them experience different situations and learning to adapt and adjust. We need to allow them to develop repetition, hitting this board at the right time without repetition, right? Then look at that variability. They're not doing the same stride pattern. And this really counters a lot of what has gone on in the coaching of long jumping, where there's a tendency on focusing on the consistency of the run up. A lot of times people do drills where they take the takeoff board away so they can focus on you doing a very rhythmic, hitting the stride every time. Clearly, this doesn't seem would be a good strategy, because controlling the long jump run up is all about using information from the takeoff board, right, to regulate your steps in the timing of the steps in the run up, and also removing the actual takeoff itself, kind of decoupling, right? You're breaking the action apart, decomposing it, is not likely going to be a good strategy either, because it's taking away the athlete's ability to develop that functional variability, those adjustments, right? So again, this points to some interesting training implications. Okay, that's it for this article. Again, you can find all my information and about my podcast and links to these other studies I've reviewed at perceptionaction.com. Thanks very much, and cheers for now.